Hey y'all, welcome to today's video. In this one, we're going to be learning how to find the equation for a line that is non-proportional. So again, our question asks us, what if the relationship is linear but not proportional? How does the equation change? Again, recall back to what we did for our stretch and mind break, where we found for proportional relationships, we can simplify them down to the equation y equals mx. So we're going to take that concept and do something very similar, this time with our graph. So the first thing that we need to do is identify a couple of points to use in our equation. So for example, I'm going to use this point B because I know as a y-intercept, its coordinate point is going to be 0, comma, B. The second point I'm going to try and use, looking out and seeing, I can use this point up here because it's labeled as y and x. Even though it's not a number specifically, it still gives me some information about what that point is going to be. So let's think back about our flow chart where we have two different options based on the information that we have. So first, yes, I can say that I do have a graph, but the only thing I can really count would be this segment here because I know for a fact that this is going to be 1, but there's no other point that I can count out. I'm not sure how high this is. I'm not sure the difference between this line is. So there's not a whole lot I can do after that. So using delta y over delta x is not going to be my best strategy in this case. So again, this is not going to be our best strategy. Instead, think about the information that we do have. We know that we have 0b and another coordinate pair. Oops, sorry. This should say x and then y. My apologies on that one. Sorry. So again, make sure that you correct this. Again, x's come first, then it is the y's. My fault on that one. But again, going back to the point that we do have two pairs that we can use for this situation. So that means I can use my equation m equals y2 minus y1 over x2 minus x1. And so thinking back to our flow chart, I know that I have to label one of these as my first pair and one as my second. So I'm just going to keep it simple, call these 1 and 2. And now I can start plugging my information into my equation. So I have m is equal, my y2 is y, my y1 is b. So I got y minus b in my numerator. Then I have x2 is just x minus 0 in my denominator. So I can go ahead and start simplifying this down. Again, anything minus 0, it's not going to change this number. So I don't really have to worry about writing that 0 out. So I can just write it as m is equal to y minus b all over x. So now at this point, we can start looking at what steps I need to take to get y by itself. Again, when we write out an equation, I want to make sure that y is isolated by itself on one side and all of my other information is on the other side. So that means I need to figure out to move a way to move my x. I need to figure out a way to move my b. So this is where it's going to be really important to remember those orders of operation, PEMDAS. We want to keep those consistent as we're moving through. So again, what that means, I don't have any parentheses, I don't have exponents, but I do have multiplication and division going on with my x in the denominator. So remember, our first step in a problem like this is I want to get rid of this x and move it to my other side. So when we have some term in my denominator and we want to move it over, remember we're going to multiply by that term to both sides of my equation. Because again, what that does is makes this x over x, Again, x over x is just 1, so we don't have to worry about it. And on the other side, I have the term mx, which is already a good sign because what we got for our proportional relationship. But I still got to figure out what happens with this b. So again, if it helps, remember we're going to draw lines through our equations to make sure that we symbolize what happens on one side needs to happen on the other. So now I got to figure out a way to get rid of this negative b. And remember, with operations, we always do the opposite. Since this x is being divided, we multiply it to both sides. Since this b is being subtracted, we're going to add it to both sides. And so what that's going to leave us with is a y on one side all alone, and then mx being multiplied together. And at the end, I'm going to tack on my plus b. Again, it's canceled on one side, added to the other. So I'm left with this equation, y equals mx plus b, something that we've seen before, but now I want to make sure that we officially stamp down. So in case you couldn't see it, because I know that color is a little bit lighter. And so this is going to be the equation that we use for almost any single line. So what this means is I can plug in a y, I can plug in an x, and solve for my missing variable.